Hello everybody, this is Algebra 2 Math for Rough Math, and here's my contact email if you need PowerPoints or videos or worksheets or correction PowerPoints. Email me, y'all, okay? 2.1 Algebra 2, use properties of exponents. We have 22 points in the class worksheets and 17 points for notebook taking, for taking notes. So students, get ready to take lots of notes in this class, in this lesson here. Here's the bell work here, copy and complete. For here, for students coming in the classroom, get ready to do this. Teachers, implement this. And then for homeschoolers, this is a good warm-up for homeschoolers for this lesson. Before, you've evaluated powers. Now, you will simplify expressions involving powers. Why? So you can compare volumes of two stars, as in example 5. Consider what happens when you multiply two powers that have the same base. So 2 to the third times 2 to the fifth equals 2 to the eighth. What do we do here? We're adding exponents. Note that exponent 8 and product is the sum of the exponents of 3 and 5 here. So you're adding exponents here. This class worksheet number 2. So now we go into a table. Yeah, we go into a table here. Cool table. Properties of exponents. Let A and B be real numbers. Property name, definition, example. So product of powers. Here's our product of powers here. And then we have a real numerical example here. Students, this is your classwork. This is on your classwork sheet, page 3. Then power of a power, blah, blah, blah. Here we have a to the m to the nth. And then here's a numerical example here again. Power of a product, ab to the m. So here is an example here of power of product. And here's a numerical example of that. Negative exponent. Here, it's a reciprocate this power here. And then here's a numerical example of that. And then zero exponent, negative 89 to the 0 equals 1. And quotient of powers, with a to the m minus n. Here, a to the m minus n. And then here is a numerical example of that here. Negative 3 minus a negative 6 equals 6 to the third. And then a power of a quotient, a over b to the mth here. And then here is a numerical. So these are very important properties of exponents for your further mathematical education students. So example 1, evaluate numerical expressions. So here is a here, power of a product. So we multiply through here, don't we? 2 to the negative 4 to the second power, and then 2 to the fifth to the second power. And then negative 4 squared is 16 times 2 to the fifth squared is this power of power here. So 16 times 2 to the 10th equals this humongous number here. And then example 1 again, the extension here for b. And then this is like to the negative 1 power, this quantity here to the negative 1. What do we do with that? What we do is we flip it. This reciprocates this whole like quotient here, negative exponent property. So we have 11, 8 to the minus 5 power, because we're using the quotient power of exponents. And that gives us 1331. 11 cubed is 1331. First, got to practice here, okay, for 2.1, Algebra 2. Tell which properties of exponents you used here. So we have 4 squared cubed, and then students, this is your problem here, okay, for you to handle. Okay, till we have some notes here. Ignore that. So 4 squared cubed is 4 squared cubed equals 4 to the 6th power. What's 4 to the 6th? It's 4096. Power of a power. We're using power of power here. 3 times 2 is 6. 4 to the 6th. Scientific notation. Now we jump into scientific notation here, because this is really suggestive for scientific notation of what we're doing here. For if it is in the form of c times 10 to the nth, where 1 is less than or equal to c, and c is less than or equal to 10, and n is an integer here, 10 to the integer. When you work with numbers and scientific notation and properties, exponents can make calculations easier. Scientific notation. So here is a good example of a definition of scientific notation is right here. So we move into example 2, use scientific notation in real life. We have 1200 square kilometers here, and we have 85 million locusts per square millimeters. Number of locusts equals locusts per square meter times number of square kilometers. So we just plug in here 85, and we're coming from up here. 85 million is this number here. So we have 85 million locusts times 1200 square kilometers. We're talking about a big number here, kids. Yeah? So 8.5 times 10 to the 7th times 1.2 times 10 cubed. That's the product here that we're looking at. So we move this over to here, 1.2 times 8.5. And then we move this over here, 10.7 times 10 to the 3rd. So we have this here equals 10.2, and then here we add exponents here, 10.2 times 10 to the 10th. So we have 1.2, and then we move this over to here, we move the decimal over. So now we have times 10.1 times 10 to the 10th. So we make this so it's a scientific notation here. 8.5 times 1.2 is 10.2. That's more than 10. That's more than 10. So we need to factor out a 10. So we have 1.02 times 10 to the 1 times 10 to the 10th. Okay, you get that? You should. If not, ask your teacher. So 1.02 times 10 to the 11th, that product of powers here. What is that? Number of locusts is 1.02 times 10 to the 11th is about this humongous number here. Yeah, I don't know what that is. It's like a trillion. 102,000 million. I think it's trillion is what that's humongous right there. 1.02 times 10 to the 11th. So, whoa, write the answer in scientific notation from our guided practice. Here is our problem here, 4.2. So of course we're going to move this over here. This is going to be moved over here. So we have 4.2, 1.5 times 4.2 equals 4.2 times 1.5 times 10.3. We'll move this over here times 10.6. So this is 6.3, and then this is 10.9. And then we move into example 3, simplify expressions. A, b to negative 4, blah, blah, blah. So what do we do there? We add, right? 6 and 7 is what? 13 minus 4 is b to the 9th. And then we have b here. B is r to the negative 2 over s third to the cube power, and this is to the negative third power. So we use the power of quotient property, we multiply through by this. So we end up negative 3 times negative 2 is positive 6, and then negative 3 times 3 is negative 9. So we have, and then negative 9 will move up to here. So you have r to the 6th s to the 9th power by using the negative exponent property. And then we have c here for this example 3 part C. So 8m to the 4th n to the negative 5th quotient powers minus to the negative 5th. So these cancel here, so they become 8th here. And then we move n to the negative 5th up here is what we do. So we have m to the 4th stays the same, n to the negative 5th, okay, that stays the same, but yet we subtract n to the negative 5th up here. So we subtract n to the negative 5th. This becomes positive, don't it? I mean, n to the negative 5th minus the negative 5th, that becomes n to the 0, which is 1. So we n to the 0, 8m to the 4th, n to the 0 just becomes, this becomes 1, so it becomes 8m to the 4th, yes? Now we have a guided practice here. Simplify expression, tell which properties of exponents to use. This is you, students. Simplify, tell which properties of exponents to use if you really want to score well on that. And I'll guide you through this one here. Okay, so here's our original expression. So we're going to x to the negative 6. We're going to add here. We're going to use product of powers here. We're going to add these exponents here. Product of powers. So we come up with x squared, negative 6. 5 and 3 is 8. Negative 6, so this is x squared. Then we go into our homework here for 2.1. State the name of the property illustrated. So you need to know your exponent properties here to do this. Writing is the number blah 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 in scientific notation. Explain. So you need to know your definitions there of scientific notation. Evaluate the expression. Tell which properties. So this is all about properties of exponents here, class. And then same thing here. Same thing. Same thing here. Tell which properties of exponents you're using here. Here and here. Same thing here. Properties of exponents. We're on page 6 of your homework. Same thing here, right through page 7. Scientific notation, write the answer in scientific notation. So you've done this, you can do this. And that is it. For further information about ordering for PowerPoints and videos, contact me at this email, and have a nice day.